Recording has started.
Okay, it looks like you're finishing up, so let's see what you have so far. If you're not quite done, that's okay. We'll see what you've done so far. Now, each of these systems was set up to be easiest to solve with a particular method. So if we look at the first one here, I'll label them equations A and B again. This one is already lined up. X's, Y's, equals, and constants. So it's already set to go for the addition method or elimination. We look at it, we realize nothing's going to disappear, but the x variable has coefficients of 3 and 2, which would make the least common multiple just a 6, and one of them is already negative. So if I multiply the top equation by 2 and the bottom by 3, I'll get the x to be eliminated when I add the equations. So we'll do that. 2 times 3x is 6x. 2 times 5y is 10y equals 2 times 31 is that correct? It is. Okay, it is 62. On bottom, I have 3 times negative 2x is negative 6x. 3 times 3y is 9y equals 3 times 11 is 33. Now, if we add our equations, we see that the x variable is eliminated. 6x plus negative 6x is 0x, so x is gone. 10y plus 9y is 19y equals 62 plus 33 is 95. And now we just divide by 19, get y equals 5. Now we have to find x. We can put y equals 5 back into either equation that we started with. I'm going to put it in the top one because there's no negatives there. So 3x plus 5y is going to become 5 times 5 equals 31. 5 times 5 is 25. So we have 3x plus 25 equals 31. We'll subtract 25 from each side. 3x equals 6. And we divide by 3 to get x equals 2. So our solution to this system is x equals 2 when y equals 5. So we get that ordered pair 2, 5. Now, as always, if this were a quiz or a test and I wanted to double check that answer, I could go back up here and put 2 in for x and 5 in for y and make sure that works. Do the same here, put 2 in for x and 5 in for y and make sure that works. For our second system here, if we were going to try to use elimination, first thing we'd notice is that first equation's lined up incorrectly. It's x's, oops, I got to correct this, I'm sorry, that should have been a 2y, not an x. It was really lined up poorly with a second x in there. Should have been x equals 2y plus 7. So it's lined up x's equals y and constant. That's all wrong for our addition method. So we would have to rearrange that to be able to solve it. Now I'm guessing you didn't get this one right because I had it written wrong. So let's go through it. The top equation, equation A, is already solved for x. So if I want to use substitution, all I have to do is put that into equation B where the x is. So instead of 3x, I can write in 3 times 2y plus 7 minus 4y equals 19. And now I'll just distribute the 3. 3 times 2y is 6y. 3 times 7 is 21. The negative 4y here is outside the parentheses, so it does not get multiplied. But I can still combine on the left side there. 6y and negative 4y is just 2y plus 21 equals 19. Now I will subtract 21 from both sides. 2y equals negative 2. And I'll divide by 2 to get y equals negative 1. Now, I can find y really quickly by using that top equation that's solved for y. I have x equals 2y is going to become 2 times negative 1 plus 7. 2 times negative 1 is negative 2, so x equals negative 2 plus 7. And negative 2 plus 7 is 5, so x equals 5. So the solution to that system is x equals 5 when y equals negative 1. So that's the ordered pair 5, negative 1. So that system was less work to solve if we use substitution. Once I wrote it correctly again. Sorry about that. This third system here, both equations are in that y equals form. They're graphing form. I could try to rearrange them, x, y equals constant, but I'm going to have fractions in it, which makes it really rough to find least common multiples. I could do substitution and just set this equal to that, but again, I have those fractions to work with. It's going to be kind of an ugly calculation. This one actually works out fairly easily with graphing. So that top equation there, y equals negative 1/2 x plus 3. I go up 3 from the origin. That's my first point. Negative 1/2 means I go down 1 and run 2. Get to my next point. Let's do it again. Down 1, run 2. Get to my, put a third point up there. So my line goes through those points. Second equation, I start at negative 2. And my slope of 3/4 x means I go up 3 and run 4, which puts us right on that point. So conveniently, the slope points overlap, so we can get a solution here rather quickly of 4, 1. Now, just like any other system, if you're not sure of that, you can put 1 back in for y and 4 in for x in both equations and make sure it's true. The point of doing these three here is that most people develop their favorite method of solving an equation. For me, it's the addition method. It's usually shorter, and I just think it's neater, less chance of mistake, less working with symbols, put it that way. But if you try to force that one method on every system of equations, there are times where you're going to force yourself to do a lot of work. When you see a system like this where one equation is already solved for a variable and there's no fractions or decimals to deal with, substitution should be a lot easier. So it's okay to have your favorite method, I do, but it's good, it's very handy, it's worth it to remember the other methods and be able to use them in certain cases, because there are some systems that are going to be a lot easier by one method over the others. Now, with that said, we're going to do some review today. I'm going to have you solve using, let's have you start out with graphing here. We'll say solve by graphing, not using graphing. That doesn't matter. So for our first system here, y equals 2/3 x minus 1. And 2x minus y equals 9. And our second one, I let you start on that one, solved by graphing, as I put the second one up here. Let's take a look and see how these are going for you. So for the first ones here, the top equation's ready to go. We start at -1, and from there we rise 2, and we run 3. I'll put a point there, then we'll do it again. We'll rise 2, and we'll run 3. And our line goes through those points. Second equation here, we got to do a little work. We're going to have to subtract 2x from both sides. -y equals 9 minus 2x. And we'll divide by -1 to get y by itself. Y equals -9 plus 2x. So that one starts down here at -9. It goes up 2 over 1. And we see it actually, if I repeat that, it actually does intersect on that slope point right there, which is at 6, 3. That was a tough one just because this point was so far away from that y-intercept. Had to be really careful. Notice I just kept repeating the slope to get up there. But we had to be very careful to make sure we intersected the right spot. So for the second system here, equation A has to be solved. 4x plus y equals 12. I'm going to subtract 4x from both sides. So y equals 12 minus 4x. So I have to get up to 12 here. Extend that axis up. So 12, there's my first point. And I go down 4 over 1 to get to my next point. Let's do that one more time. Down 4 over 1. Making sure I counted right there. So there's my line for that one. Second one here, we're going to have to work a little bit harder at. We have to subtract 3x. We get 2y equals 14 minus 3x. And we'll divide by 2. Y equals 7. Negative 3x divided by 2 is a negative 3 halves x. So we start at positive 7, which is right here. We go down 3, run 2, which puts us right on that slope point. That solution there, we can see they overlap at the point 2 comma 4. Next, let's review some substitution. So these two systems I want you to solve using substitution. So 2x plus 3y equals 6. And x plus 4y equals 13. So let's just start on that one as I put up the second equation. Okay, let's take a look. So for the first one here, equation B is actually set up to be relatively simple to solve for x. So let's do that. We're just going to subtract 4y. We get x equals 13 minus 4y. That's still equation B. We've just modified it. We've solved for x. Now we have to go back to equation A, and we'll replace x with 13 minus 4y. Now we have one equation with one variable. We can solve that for y. So we'll distribute the 2. 2 times 13 is 26. 2 times negative 4y is negative 8y. The positive 3y is not in the parentheses, so it does not get multiplied. We will combine negative 8y and positive 3y is a negative 5y equals 6. And now we'll solve. We'll subtract 26. Negative 5y equals negative 20. 6 minus 26 is negative 20. And we'll divide by negative 5. You get y equals 4. Now we can find x by going back up to this equation and putting 4 in for y. X equals 13 minus 4y becomes 4 times 4. X equals 13 minus 4 times 4 is 16. Well, 13 minus 16 is a negative 3, so x is negative 3. So the solution there, x is negative 3 when y is 4, is our ordered pair. System number 2 over here, we have to be just a touch careful. The top equation would be fairly easy to solve for y, but we have that negative in front of the y, the minus in front of the y that we'd have to be careful of. Our second equation is actually very simple to solve for y. So I'm just going to label them A and B again. So we're going to solve equation B for y by subtracting 3x. So we get y equals 11 minus 3x. That's our equation B, still just rearranged to be solved for y. Now, when we go back up to put that in equation A, we have to be careful. So 2x minus y is where we have to be careful. That minus in front of y, we're going to treat that like a negative 1 times y. So we'll put in the 11 minus 3x for y equals 14. So the 2x doesn't change, but we do have to distribute the negative 1. Negative 1 times 11 is negative 11. Negative 1 times negative 3x is a positive 3x. We're still combining there. We will combine the 2x and 3x to get 5x minus 11 equals 14. We will add 11 to both sides. 5x equals 25, and then divide by 5. X equals 5. Now, of course, we can go back to find y by using this equation here and putting 5 in for x. So 11 minus 3x becomes 11 minus 3 times 5. 3 times 5 is 15. So y equals 11 minus 15. 11 minus 15 is negative 4. So y is negative 4. So our solution here, x is 5 when y is negative 4, giving us that ordered pair 5, negative 4. So substitution, hopefully everybody has down. Any questions on those two systems? Okay. So next, we're going to have you solve or elimination, whichever you prefer to call it. So our first system here, we have 3x minus 2y equals 4. Negative 2x plus 3y equals negative 11. I'll let you work on that as I set up the second one here. Okay, let's take a look at these and see how you're doing. So for number 1 here, I'm going to label them equation A and B again. These are set up in the correct order. X's, Y's equals constants. So we can just look at common multiples. Both of them have coefficients of 2 and 3. So their common multiple would be 6. Both of them have one positive and one negative. So it really makes no difference which variable we do here. I'm going to get rid of x since it's right there. So I'm going to multiply the top equation by 2, bottom equation by 3. So this top equation becomes 2 times 3 is 6x. 2 times negative y is negative 4y equals 2 times 4 is 8. Equation B, 3 times negative 2 is negative 6x. 3 times 3y is 9y equals 3 times negative 11 is negative 33. Now when we add these equations, 6x and negative 6x is 0x, that disappears. Negative 4y and 5y is, or negative 4y and 9y makes 5y equals 8 and negative 33 is negative 25. So for y, we'll divide by 5, get y equals negative 5. Now we do need to solve for x. I can go back to either one of these equations. I'm just going to use the top one. So 3x minus 2 times negative 5 equals 4. 2 times negative 5 is a negative 10 equals 4. Well, 3x minus a negative 10 is the same as 3x plus 10. So I will subtract 10 now to solve. 3x equals a negative 6. I divide by 3 to get x equals negative 2. So my solution to that one is x is negative 2 and y is negative 5. For our second system over here, we see that the second equation is not set up correctly. The y is on the right side of the equal sign, so we have to start by rearranging that by subtracting 3y. So I get 5x minus 3y equals 40. That's equation B. I'm just going to rewrite equation A underneath it here. 3x plus 2y equals 5. Now in this one, for x I have 5 and 3 would be a common multiple of 15. For y I have 3 and 2 would be a common multiple of negative 6. One of those is already, or would be a common multiple of 6. One of them is already negative, so let's just go ahead and get rid of the y. So we multiply equation B by 2, equation A by 3. I'll put them back in the right order, so I'll do equation A first here. 3 times 3x is 9x. 3 times 2y is 6y equals 3 times 5 is 15. Now equation B, 2 times 5x is 10x. 2 times negative 3 is negative 6y equals 2 times 40 is 80. And now we add 9x plus 10x is 19x. 6y and negative 6y is 0y. That's gone. And 15 and 80 is 95. So we divide by 19, get that x equals 5. Now we have to find y. We can go back up to either of these initial equations. I'm going to go up to the first one. So 3x becomes 3 times 5 plus 2y equals 5. 3 times 5 is 15 plus 2y equals 5. Subtract 15. 2y equals negative 10. And divide by 2. Y equals negative 5. So the solution we get here is x equals positive 5 when y equals negative 5 to give us that ordered pair. I'm sure you're probably getting tired of systems of equations by now, but I wanted to do a good review today because there is a quiz out there. Quiz 12-10B is out there for today. It's due at noon tomorrow. Because of the break, if as long as you get it in by Monday noon, I'll be okay with that. I realize some of you have to run off after class today for family stuff. To give you an idea of the schedule looking at, there is no other homework today other than doing the quiz. When we come back from break on Tuesday, December 1st, we're going to take a look at applications. In other words, where do you use systems of equations and some of the other equations that we've worked with? Wednesday, December 2nd, is going to be the Unit 3 test. So we are wrapping up Unit 3 here as we get back from break. So just so you are prepared for today, that didn't work. Quiz 12-10B is all you have to do between now and Monday. Any questions? Okay, well, we only have about 2 minutes left, so we'll let you guys out of here. You guys have a great, safe, and healthy Thanksgiving, and we'll see you next week.